Welcome to Module 2, Linux Introduction. So in this module, we're going to talk about some of the fundamental concepts of Linux. Then we'll go through another demo similar to Module 1, where I'll walk through some command line stuff, just showing how these commands work and how we can use them. And then lastly, we'll do another in-class exercise, which will show how we can use some of these command line capabilities to copy and remote into a remote system. So for example, we have our master, which will be the Raspberry Pi connected to your computer, and then we'll have the robot, which will be roaming around connected to your Wi-Fi. The Raspberry Pi will still be connected to the Wi-Fi, but you won't have a monitor and keyboard to access it. So we're going to use the master and secure copy and secure shell, so remote into that system so that we can still access the command line without actually having to take the robot, connect it to a keyboard, a mouse, and a monitor, and then that allows us to kind of have that flexibility so that we can access that computer still. So that's what we're going to look at here. So let's first talk about a little bit what Linux is. So in a computer, you have an operating system, you have a kernel. An operating system is a program that runs the computer to manage the resources of the system. So it's controlling interrupts. So if I hit a keyboard key, it's controlling what the processor is doing to process that key. Hey, I have to stop doing this so I can process that key, or the mouse movement, and then all the other things that are going on in the background. If you ever looked at the Control Alt Delete to see what processes are running, there's a ton of things going on. So this allows the operating system kind of manages all that. And if you do the computer kind of track for ECE, you'll take an operating systems course that really allows you to see all the different things. And interrupts is the kind of biggest thing in the memory management. So a kernel, on the other hand, is that part of the operating system that provides the bridge between the software and the hardware. And I talk about this because it gets a little bit confusing when we say Linux. What does that mean? Linux is actually a kernel where that's kind of just the base level that's going to be communicating with that hardware. And the operating systems are Ubuntu, Debian, Raspbian. So all those are the operating systems. So what we are using on the Raspberry Pi, which is it's going to be Linux based. It's going to have a Linux kernel. It's an ARM processor, and we'll learn about that later. It's not important to this class, but you'll see that in 3D2. And but the operating system we have loaded on both the master and the robot is Ubuntu. I think it's Ubuntu 18.04, and so that's just kind of the version of the operating system. And so I just don't want that to get confusing. You're not using the Linux isn't the operating system. It's Ubuntu is the operating system. So that's similar to Windows 10 is the operating system, and they call it Windows NT is the kernel. It's gone through a number of different, and then Apple, I think Mac OS. I don't know which version they're on right now, but that's based off a Unix kernel. So just some of that terminology, that kind of just allows you, to make sure we're talking about the appropriate thing when we talk operating system. So when we work with Linux, it's a bit different than Windows. So Windows is very much user interface. And Linux, a lot of the operating systems nowadays, Ubuntu, provide a user interface. So they have a nice graphical interface where you can click on Windows, you can do all of that. But a lot of the time you want to kind of ignore all of that and just use the command line, especially when you're thinking about a small computer like a Raspberry Pi that you don't want to have a whole lot of extra processes, because all of those windows are controlled by the operating system, and that takes a lot of processes and a lot of memory and RAM to kind of create. So we like Linux because we can kind of bring it down to a lower level where all you're running is maybe the command line. And instead of like Windows, it's pretty heavy. The operating system is doing a lot of stuff. Sometimes if you look at how much your processor is running when you're doing nothing, it could be all the way up to 50–60% just managing the operating system. So that is a lot of memory that's being wasted. So that's a big benefit of Linux. So when we use these command lines, that gives us access to everything that the user interface would, but we just kind of have to use all of these textual commands instead of click and drag and copy, Control C, all of that goes away, and then we have to use these textual commands. So let's take a look at some of those. So let's start with file commands. And the first set of file commands are just kind of allow you to control the directories, the directory system. So instead of opening up a user interface, seeing what your directories are, we use commands. And so the first one is the list command, which lists what directories are, or sorry, what files and folders are in the current directory. There's a lot of flags, so you can typically, any of these commands, you can do a -H or a double dash help, and I'll show you some of the commands. There's also manual pages or man. So typically if you type man and then some command, it'll bring up this whole description of what that command does. So for example, the flag, which are these values after the dash, give you a little bit more capability, and we'll see what some of that does in our demo. And so this -AL will just allow us to list more information. What are the permissions? Can I execute that file? Can I read it? Can I write it? Then it'll show any hidden files. We use the CD change directory command to go into a folder. So for example, if I wanted to go into my workspace, I would use CD and then master _ workspace. And that would get me into that workspace. If I just do CD, on the other hand, that will go straight to my home directory or root directory. So that allows us to get back to our kind of home base. You can do CD ... So CD space ... that will go up one directory, so that's a previous directory. The dot command's a single dot, so this doesn't actually do anything because the dot just means the current directory, so I just change back to the current directory. PWD allows you to show the entire path. So for example, it might be if I did PWD and I might be at home pi ... and that'll show that will be what comes out of that. Make directory, just creates a new folder, so allows us to establish those folders. We can remove files using RM. We can remove directories, so that -R is recursive, so basically you're removing the directory and all the files below it. We can copy one file from one place to another, so if we want to copy our ICE1 directory, or sorry, our subscriber or publisher, we can copy that using the copy command, and we can move it, so that would be more of like a cut and paste versus a copy. Touching allows us to create a file, so if I want to touch chat subscriber, then we can create that file. Change mode, chmod, that allows us to add the execution. You see later on, well, it's actually in our note sheet. Our little Linux note sheet has a lot more of what the capabilities with change mode are, but all we will really need is to add the executable. So we'll just use this +X, and that will make our subscribers, our publishers, all of our different nodes executable, and we'll need to do that for all of our nodes going forward. And then cat, the file that just allows you to see what's in that file without actually opening it. So that's some of the basic commands. There's not a whole lot else that you'll use in this class. I mean, there's a lot more in general, but that's the gist of what we will use in this course. Just double check that I didn't miss anything. Alright, so let's take a look at some of our network commands. So these are three of the basic ones, and one key one is missing, which is if config. And if config, what that allows us to do is look at the configuration of our current interfaces. So, and by interfaces, I mean your Wi-Fi, your LAN, stuff like that. So on the Raspberry Pi, you have built-in Wi-Fi. You also have LAN. So for example, in the 3D printer lab on base, or in the cadet area, we have, so for example, in the 3D printer lab in the department, each of those 3D printers is connected to a Raspberry Pi, and that Raspberry Pi is connected over Ethernet to the internet so we can access it. And so ifconfig allows us to look at what our IP addresses are over each of those different interfaces. And so that's really important. Ping allows us to test connectivity to another system. So we have our master, and maybe our robot's driving around and we want to access it. Well, we can use ping first in the IP address. So ping, let's just say it's 192.168.0.101. We can then access that and see if we have connectivity to that. And so that will be sending a message, and then the robot knows automatically within the operating system to respond to that. SSH, secure shell, allows us to do that remote control of that remote access to that operating system. So we have our master, our robot's driving around. We can do SSH space pi at, and then whatever the IP address is. And that will open up a new terminal as if we are on that robot Raspberry Pi. So all the commands we will be doing will be on the robot Raspberry Pi. So that allows us to access files, change files. We can do any of that we need to without having to take the Raspberry Pi, connect it to a keyboard and mouse and monitor, and it gives us a lot of capability to allow that system just stay remote. And we don't have to, all we have to do is power it on, connects to the Wi-Fi automatically, and then we can access it. We could also pass files between the two using secure copy or SCP. So it goes basically both ways. So SCP source and then destination. So I can take a file from the master and copy it to the Raspberry Pi, or I can take a file from the Raspberry Pi and copy it to the master. You just set up that source and destination. If the file is on the local computer, then all you have to do is type in the file name. But if it's on a remote computer, then that's when you need to add in that IP address. And we'll see an example of that in the demo. All right, that's those two really, the file commands and network. Those are the primary things we'll be doing. This is just kind of some extra stuff that might be helpful for you while working with Linux, whether it's in this class or a different one. That's one thing. Our majors previous to this didn't really have much experience with Linux. So this class, part of what we're trying to do is increase that experience with Linux because it's such a useful tool. I've used it in the Air Force outside of just here, but in my job as well, and a lot of times in research. So it's really useful. All right, searching. So grep allows us to search. Searching is pretty difficult. I found I always struggle with it, so I always have to do a Google search to figure out how to search, which becomes a pain, but this is kind of some of the basic commands. So if I wanted to find say I wanted to find something that said chat, and I can look in, my robot workspace, and it'll look in that folder. If I did the recursive function, it'll look in all recursive, so all the subfolders of robot workspace. And then what's somewhat helpful, I like this a lot more, is say we have a, let's say we want to list all the packages that ROS has, but we want to look for a certain one. We can do something along this line. And so instead of all of the packages that ROS has on your computer, it'll just show you which ones contain robot. And so that's this piping capability is very useful. And so basically what's happening is it takes the output of this command and pipes it into this command. So it's useful not just in searching. We use it a lot in ROS or in just in general where you want to combine two commands. So I want to take the output of this first one and send it to the input of the second one. All right, process management is important. I found this useful, especially with ROS. Sometimes Python files or scripts will break and will still be running in the background. And then after a while, you have a lot of them running, and then your Raspberry Pi just starts getting bogged down. So again, PS dash AUX again flags. If you did the PS dash help or main page, you can see what those mean. But those display all the active processes, and you can pipe that through and look for something along all the Python commands. And then you can kill, depending on what the ID of those processes are, you can kill them individually, or you just kill all star.py files, and that will kill all any process that ends with a .py. So I found that pretty useful because it can get pretty bogged down. Here is just some shortcuts. Control C is pretty important. Control C or Control Z depending on what you're doing. So for ROS, Control Z works more often than Control C. Control you don't really need to use Control D. Control U is nice. You can't do a lot of the things you can in the user interface where you're clicking and selecting everything and hitting backspace. So if you have a long command and you've messed up, Control U helps to erase that whole line. Control R will show you all the recent commands. If you do bang bang, it'll run the previous command. And then up arrow allows you to also look at some of the previous commands as well. So those are the key Linux commands that I use through ROS. I don't think, let me just double check that I didn't miss anything. I wanted to. Yep, that's about it. So the demo video will go through how these work. We'll see most of these, just mainly the ones we use in ROS. And then we'll also look at some of the ROS built-in Linux commands as well that kind of give us some extra capability.